Okay, gonna simplify the square root of -9. So I'm thinking what times itself equals -9? Well, nothing times itself is gonna equal a negative. But first off, you can see we're gonna get into cube roots and other roots. So just some vocab. This is a square root. I'm looking for something times itself, something squared. So even though there's not a little 2 written up here, it's just assumed that this is a square root because that's the most common one. And this is called the index. Okay, so my index here is 2. And so that's anytime you got a square root, the index is 2. When you have a cube root, the index is 3. Whatever number is up there is called the index. Okay. The number underneath the square root is called the radicand. Underneath the radical is the radicand. Okay, just a little vocab there. All right, so simplifying this, I can still simplify this even though there's no real number that multiplies to -9, because I can break this apart into -1 times 3 times 3, right? And anytime I have twins under there, one of them can get out of the jail. So a 3 will get out. Now I've got 3 times the square root of -1. And the square root of -1 is I. So we can write this as 3i with the little tail, right? That's our imaginary number, 3i. So there we go. We've simplified that, okay? When we're looking for a cube root, instead of looking for something multiplied by itself, we're looking for something multiplied by itself 3 times. So instead of something squared, something to the 3rd power. Okay, so I can break 8 up into 2 times 4, or even better, into 2 times 2 times 2. And using this jail kind of thing, you can still do the jailbreak thing. It's just instead of twins like you need for a square root, if you've got a cube root jail, then you need triplets. And only one of the triplets is going to get out. And so this becomes 2. And it makes sense because 2 to the 3rd equals 8. Okay? So it's tempting to think that I'm going to get an imaginary solution on this next one because I got an imaginary solution for the square root of -9. But actually, when the index is odd like it is here, you're never going to get an imaginary solution. Because you can have something multiplied by itself 3 times and get a negative number, or 5 times, or 7 times, or 9 times. It's just you can't square something or raise something to the 4th or the 6th or the 8th to get a negative number. But you can do that with these because this you could think of this as -2 times -2 times -2, right? 2 to the 3rd is 8. Whoops, sorry, writing and talking at the same. 2 to the 3rd is 8. -2 to the 3rd, well, yeah, if you multiply those together you get +4, and then multiply by -2. It does come out to -8, right? And then I've got my triplets there, and so this is going to simplify to -2. Okay. So I can also simplify this because this is, I can think of this as -1 times -1 times -1. Right? When you raise it to the 3rd power, it will come out negative. And so the cube root of -1 is -1. Okay. All right. So let's try this one out. 54. So let's start breaking up the 54. So let's see, there's lots of different multiplication problems I could do, but 9 times 6 is one of them. I'm breaking this apart looking for triplets. So let's keep breaking up the 9 into 3 times 3, and then I can break up the 6 into 3 times 2, and hey, look, I found some triplets. So one of those is going to get out. And don't forget the cube root symbol there in your final answer, okay? And I can't do anything with the 2 because it's not part of a triplet set, so it's done. So this is simple radical form of the cube root of 54, okay? All right, so let's evaluate this same thing with our calculator. So I know it's going to be equivalent to this, but I'm going to get a decimal version here, okay? So there's a couple of different ways you can do that. A lot of calculators will have a cube root button on them, and these TI graphing ones do. If you hit the math button, and then there is cube root. Right below that, there's an x root. So if I wanted the 4th root or the 5th root or the 6th root or any other root, I would use that one below. But I can use this one right here, cube root, and so I just put in 54, and then I got about 3.7, let's call that about 3.78. Okay, now an alternative way to do this, you can also take 54 and raise it to the 1/3. So 1/3, I'm hitting just 1 divided by 3 in my calculator. I'm raising 54 to the 1/3. Hey, same result. So those both work. If you wanted the 7th root, you could raise it to the 1/7. Okay. Oh, and I gave away this next one then. Use a calculator, approximate this. Well, you could raise this to the 1/7. Okay, that will work. So 20 to the 1/7. And the reason I'm putting this in parentheses here is because I don't want my calculator to raise 20 to the 1st and then divide that by 7, right? That would just be 20 divided by 7. So I'm putting it in parentheses, and I'm not. Some calculators might be smart enough to know that the 1/7 is the exponent, but I'm not taking any risks here. I got about 1.53. Okay. All right. And so let's do this the other way. So I could use, if I go and find this this thing right here. Oops, I've got my last answer times that. So here, let me clear my calculator. If I try to put this thing in right now, see, it's trying to take my last answer. I can't actually change the index here. I can put 20 as the radicand, but I can't. Some calculators will give you a little cursor there, and you can just go move up there and put the 7 in. In a calculator like this, what I have to do first is put in what I want the radical to be. Okay, so I'm going to clear that up. I'm actually going to hit 7 first, then go to math and find this thing, and then hit 20. Okay, and that's going to give me that same result. Okay, so I got about 1.53. Yeah, the newer calculators will just give you a cursor, a blinking cursor there that you can fill in. Okay. All right, on to the next page. Okay, so what we were talking about on the last page, I'm going to actually skip down to this example here. 25 raised to the 1/2, that would actually be the same as the square root of 25, right? Okay, and let's talk about where these pieces are going. The index here is 2, right? Even though you usually wouldn't write it in for a square root. And hey, that corresponds to this number right there, okay? And then what do I do with the 1? Well, the 1 is going to be an exponent. You can either put it 25 to the 1st, which is just 25, right? Or you could raise it to the 1st on the outside of the radical. It doesn't really matter. It'll work out the same either way, okay? So this number is going to go right there, okay? So using this pattern, when you've got something raised to a rational exponent here, as a fraction exponent, right? The denominator is going to become the index, and the numerator will become an exponent. Okay, so this is going to be, my index is going to be C here, and B will be the exponent. So you could write it like that, or depending on the situation, it might be handier to do this kind of a thing. It doesn't really matter if the B is inside the radical or on the outside. Okay. All right, so let's get back to this one. Hey, I can take the square root of 25. That's 5. Okay. I'm not writing plus or minus 5 because usually when we're just simplifying an expression, we only use the positive root. Okay. All right. So next up here, I'm taking the 27. That's going to be the radicand, right? 3 is going to be my index. That goes right there. And then the 1 doesn't really do much in this case. But then I've got the 3rd root of 27. Okay, so I've got the cube root of 27. So let's break apart the 27, looking for triplets, and hey, I found some, right? So cube root of 27 is going to be 3. So this is the same as the cube root of 27, okay? Now, we're not always going to have a numerator that's 1, So let's deal with that, okay? So I've got negative 32 to the 3/5. So writing this as a radical, the denominator is going to be the index, okay? And I didn't need to put that in parentheses. I just wrote that without thinking. But and then I can put the 3 either in here. I would actually rather try to find the 5th root of negative 32 and then raise it to the 3rd. But you could do it either way. Okay. So now let's look at this. Okay. Now I'm thinking, what raised to the 5th power equals negative 32? Well, you could put this in your calculator, right? You could put in the 5th, the 5th root. So I had 5, then math, and then go down to this thing, and then put in negative 32. And don't put minus 32, right? Negative. You want to use the negative button down here. Okay. And then I've got negative 2. Okay, negative 2 to the 5th power does equal negative 32. So then I've got negative 2 raised to the 3rd, and I'm just thinking negative 2 times negative 2 times negative 2. That's all going to come out negative 8. Okay. And just to try this out, you could also, just put this in your calculator as it is. So I could put in negative 32 raised to the 3/5. And let's see if we get the same result. And we do, right? But it is useful to be able to go back and forth from radicals to rational exponents, because a lot of times we'll have variables, and it's not as simple as just typing it in your calculator. Okay? All right. So a negative exponent, hopefully you've seen this before, but when I have a negative exponent, this is going to be equivalent to 1 to the x third. So usually when you have a negative exponent, you want to rewrite it with a positive exponent, okay? So actually in simple radical form, you're not supposed to have negative exponents. So no, I'm writing no negative exponents in simple radical form. Okay. All right, so that was a pretty straightforward one. I can't really do anything else with that. All right, so I've got a negative exponent on this next one. So the first thing I'm going to do is rewrite this with a positive exponent the same way I did up here. So this will be 1 over 16 to the 5/4. Okay, so there's step 1. Okay. Now I'm going to rewrite the denominator as a radical. So I'm going to leave the top alone for now, the numerator. But this is going to be the 4th root of 16, and I could put the 5 inside or out. I think I'd rather than raising 16 to the 5th right now and then trying to find the 4th root, I think it's easier to take the 4th root when you got the smaller number. And actually, that's something I can do in my head. I'm thinking, what raised to the 4th power is going to equal 16? Well, I know 4 times 4 is 16, so that's 2 to the 4th, right? So 2 to the 4th is 16. That means that all simplifies to 2, okay? And you could always use your calculator, right, to get the 4th root of 16 as well. And then 2 to the 5th comes out to 32. And look at that. I simplified this, which looks pretty complicated, but I simplified it without a calculator at all, using those laws of rational exponents, okay? All right, next up, we're going to solve some equations. So if this were squared, I want to take the square root of both sides to get rid of the exponent. So instead of doing that, I'm going to take the 4th root of both sides. Here, so let me write it like this first. Okay, so the 4th root of x plus 3 is just going to, x plus 3 to the 4th, is just going to be x plus 3, right? Now, whenever you're taking an even index of, so when you're taking the square root or the 4th root or the 6th root or something like that of both sides of an equation, then you need to deal with the positive and negative. So you need the plus minus in there on the other side, okay? So in a nutshell, when you've got an even index, this is when you're taking a radical of both sides of an equation. If it's an even index, then you should have the plus minus in there, okay? So I'm going to isolate the x here. Okay, I've got it like that now, and now I'm going to start putting this, oops, I forgot the fourth root on both of these. I'm going to start trying to put this in simple radical form. Okay, so I'm going to break apart the 24. Let's see, that would be 4 times 6, right? Or 2 times 2, that's the 4, and then 6 would be 2 times 3. And hey, I found some triplets, but I did not find any quadruplets like I'd be looking for here since the index is 4. So I can't really simplify this any further. This is good to go in simple radical form, okay? All right, let's try this one. I'm going to take the cube root of both sides. And since this is a cube root, I don't need to worry about the plus minus thing. I'm just going to leave this as it is. So x minus 3 is going to equal the cube root of 128. Okay? And I'm going to start breaking up 128. And I'm going to use a calculator just to make it quicker. So I know it's an even number. I can divide it by 2. Let's see. Then I've got 64. Hey, 64 is 8 times 8, right? So x minus 3 is going to equal the cube root of 2, and then I had 64, which was 8 times 8. Okay, now if I was looking for twins, I'd be in good shape, but I'm looking for triplets, so I'm going to break up those 8s further. Okay, and also at some point, it doesn't matter if you do it now or later, you're going to want to move the 3 over to the other side, and I usually like to put it in front. You could put it behind the radical, but then it's sometimes confusing whether the 3 is underneath the roof or not. So I'm going to put it out there, okay? Now 8 is 2 times 2 times 2. And then I've got another 8, another 2 times 2 times 2, okay? And then I'm looking for triplets. Let's see, there's a set of triplets, there's a set. So 1 from each of those is going to get out, and then I'm going to have 1, 2 trapped in there forever. So let's see. Okay, and then the 2 2's that got out, I multiply them together. And a lot of times I see people forget to write the index, so just be mindful of that. And unless it's a square root, you got to always write the index in there, at least in the final answers. You should really write it as you go along the way too. Okay, that's supposed to be a 3 there, and it's my index. Okay, and that's it for today. See you next time.